the first question is that what is real time? Actually, in the simplest term, we can say that real time is a quantitative notion of time measured using a physical clock. But then we will have the question that then this is the time. So, how is it different from other systems? They also deal with time. But then here we measure the time explicitly using a physical clock in a real time situation, and then if the time bounds are not met, we say that the system has failed. Just to give an example of a real time system, let us say that in a chemical reactor, if the temperature exceeds 500 degrees, then the coolant shower must be turned on within 100 milliseconds. So, here once the temperature exceeds 500 degrees, then we need to set a physical clock and then check whether the coolant shower is actually getting on within 100 millisecond, otherwise the system would be considered as failed. In contrast, in a traditional system, we have the notion of a qualitative notion of time. In a traditional non-real time system, we use terms like before, after, sometime, eventually. For example, we might say that in a library, before a book can be issued by a member, the book records must have been created. The book must have been procured and entered in the system's library. So, just mark here that we are saying that before the member can issue the book must have been entered into the system. But then when exactly it would have been entered, not specifying anything, it could have been entered the previous day, previous hour, or maybe several years back. So, in the traditional systems, we do not use a explicit notion of time, we just use a qualitative notion of time like before, after, sometime, etc. So, in every real time system, we have events occurring and then the action must be taken before some time. So, that we call as the time constrained response to the events, and often these systems are embedded and safety critical. So, we will see what is an embedded system and what is a safety critical system. The embedded systems are the ones where the processor, the computer, the software is part of the system and it controls the system. So, the computer system is embedded within the physical system. There are many examples of an embedded system, hundreds of thousands of examples. For example, let us say a robo, or let us say a toy, electronic toy, or maybe let us say a nuclear reactor, or maybe let us say in an automobile there are embedded processors which control the fuel injection, or let us say the environmental control like temperature, etc. So, there are numerous embedded computers around us, and what we want to really say is that the embedded systems, majority of them are actually real time systems, but then there are other real time systems which may not be actually embedded. For example, let us say a air traffic controller in an airport, it reacts to a aircraft coming in, and that is not really an embedded system. So, we have majority of the real time systems are embedded systems, but not all embedded systems are real time systems as shown in this diagram, and also there are some real time systems which are not embedded, and many of these are safety critical in the sense that if there is a failure in the system, it can cause financial or physical damage. So, maybe life, property, etc. So, that is a safety critical system. Just giving an example of a nuclear reactor. So, if there is a failure, it can cause severe disasters, loss of life, property, and so on. So, the next question is that what is the role of the real time operating system in these real time systems? Actually, the real time operating systems, the primary purpose is to help the tasks meet their deadlines. There are other features of the real time operating systems, as you will see, but the primary feature of a real time operating system is that it lets real time applications meet their deadlines. But then the question is that how does a real time operating system help the tasks to meet their deadline? The answer is that the real time operating systems have a task scheduler, and it is the task scheduler which is the primary mechanism used by the real time operating systems to meet the